So the next step with our percents, start calculating with them. Okay, maybe. There we go. When we dealt with turning a fraction back into a percent, if we had something like 5/7, that's 5 out of 7 is a ratio. Remember, a percent is a ratio, but it's always out of 100. Well, trying to figure out what you multiply 7 by to turn it into 100 is going to take a while. So the shortcut we learned was cross multiply. The two numbers that are diagonal get multiplied. So 5 times 100 is 500. And then the number that's diagonal with our missing piece, we divide by. So we divide by 7. And of course, 500 divided by 7 is going to be 71.428574143 approximately. Yes, no. I didn't actually have it wrote down. But I'll guarantee it's right. So it rounded out to 71.43%. Okay. This setup here, where we have, it's really not a fraction, but it looks like one fraction equal to another fraction. 1/4. Oh, no, your calculator rounded it off there. I just went one digit past what your calculator did. So it's not my fault that your calculator's slacking off and only went to 10 digits. So anyway, this setup where we have that appearance of one fraction equal to another fraction, it's really one ratio equal to another ratio. It's called a proportion. And that leads us to our first method of working with percents, called the proportion method. Now, if you're taking notes, note that I'm leaving this side over here blank. I'm going to come back and redo each of these problems with another method later. So anyway, the first problem we'll look at is find 35% of 84. So when we do these, I always start with the percent. So 35% is that ratio of 35 out of 100. Now, before we do the rest of this, let's talk about what those two parts of this ratio mean. The 100 here on bottom is actually a percent. 100% is the full amount. We refer to it as the base amount. The reason it's called the base amount is because that's the amount that all of our other calculations are based off of. If you're doing a discount, that would be the full price that you're using to find the discount. It's the number you're using to find the percent that we're looking for. So it's often the starting amount or the whole thing. The top number then is called the portion of interest. It is the piece of that base amount. Now, sometimes it's actually bigger than the base amount, but it is a portion of that base amount that we are focusing in on for this particular problem. So now on the other side of this, the numbers have to match up. Now here we have the number 84. Can you tell me if that's going to go on top or bottom? Of 84. You can read it as out of 84, which would imply it goes on the bottom. And now just like we did with our up above with our other proportions, we cross, multiply, and divide. What two numbers get multiplied here? 35 times 84, which gives us 2940 is correct. Then we divide by the 100 to get 29.4. So 35% of 84 is 29.4. We might have blank is 140% of 60. So we start with our percent. What's our percent here? 140. So 140 out of 100. Now the thing you'll notice here that the 140 is bigger than 100. So that means our portion of interest is actually going to be bigger than the base amount. Where does the 60 go? Top or bottom? Bottom. Again, you think of that as out of 60. What do we multiply? 140 times 60, which is 8,400. And then divide by the 100 to get 84. So 84 is 140% of 60. So you can see there, because the percent was bigger than 100, that portion of interest was bigger than the base amount. We might have 70% of 30 is blank. So again, what's our percent here? 70. So we start off with 70 over 100. On the other side, where's the 30 go? On bottom. It's still of 30, out of 30. It's the 30 on bottom. To calculate, what gets multiplied? 70 times 30 is 2,100, and then divide by 100 to get 21. 70% of 30 is 21. So, go ahead. Do you have a question? All these problems here are worded differently, but you'll notice they were set up exactly the same way in the proportion. They can be different, though. We might have 28 is 70% of blank. So here, what's our percent? 70. So we start out with 70 over 100 equals, does the 28 go on top or bottom? Top. It says 28 is 70%. That implies the 28 matches up with the 70. Of blank, out of blank implies the missing numbers on bottom. What gets multiplied this time? 100 times 28 is 2,800. Divided by 70 is 40. So 28 is 70% of 40. So here you can see the missing number was in a different spot in our proportion, but the calculation was still the same. Cross, multiply, and divide. And we might have 40% of blank is, oh, let's do 52. What's my percent here? 40. So 40%, 40 over 100. Where's the 52 go? Is 52, right? On top. Of blank, again, think of that as out of blank. It implies that missing number goes on bottom. So now, when we calculate, what gets multiplied? 100 times 52 is 5,200. And then divide by 40 gives us 130. Good. 40% of 130 is 52. So our next one we have here, 32 is blank percent of 80. So we've said that we always start with the percent, but here we don't have the percent, which doesn't change anything. We just make it blank over 100. Now that missing percent is what we're going to be looking for, what we're trying to find. So we're going to have both of the numbers on the other side. Which one's going to go on top? 32. Yes, it says 32 is blank percent. That implies the 32 goes with the missing percent. Then, of course, on bottom will be 80. Cross multiplying, what gets multiplied? 100 times 32 is 3,200, and then divide by 80 is 40. So that's 40 out of 100, or 40%. So you can see again, it's the missing numbers in a different spot of our proportion, but the calculation is still the same. Cross, multiply, and divide. Now the proportion is a little clumsy to do because you almost have to write it down to see where things are, to see what you multiply and what you divide. but I do find that that's the one that people make the fewest mistakes with. The second method we're going to look at is a little bit quicker to do, especially if you're just punching numbers in the calculator. It's real easy to just spit out an answer, but I find people make more mistakes with it. So this is the rate method of percents. And what the rate method is the first step is you take the percent and you turn it into a rate. So the percent in this first problem is 35%. What is that as a rate? Its decimal form will be 0.35. We just divide by 100, right? Now the rest of this depends on what information you have. We've been given that base amount. When we're given the base amount, you can find the portion by taking the base times the rate. So here, the base amount is the 84 times the rate of 0.35 gives us 29.4. Well, that's, again, a little quicker and easier. All it requires us to do is to be able to very quickly convert that percent into a rate. Just moving a decimal point is all it is. So for this next one, we have a percent of 140%. What's that become as a rate? 1.4, good. So then what's our calculation going to be here? That's our base amount. So 60 times 1.4 gives us 84 is our portion. Again, quicker and easier than setting up the proportion. So for this one, what's our percent for this next one? 70%. What's that going to be as a rate? 0.7. What do we do next? 30 times 0.7 gives us the 21 as our portion. So there, on all three of those, we saw much quicker and easier than doing the proportion. The reason I say the proportion produces less mistakes is because we run into ones like this next problem. So here we have the percent, which is 70%, which becomes what is a rate? 0.7. Do we have the base amount here, though? No, we had the top number, not the bottom number. So what we have here is the portion. Well, when that's the case, we're looking for the base. We take the portion, we have to divide by the rate. So here we have the 28 divided by the 0.7 gives us 40. So the problem with the rate method is it is quicker and easier, especially if you're punching in the calculator. You can punch it into the calculator directly without having to set up the proportion. But you have to be able to figure out, am I multiplying by that rate or am I dividing by that rate? So like this one here, what's our percent that we're working with? 40%. What's that become as a rate? 0.4. What's our calculation going to be then? 52 divided by 0.4, which is 130. And then we have even different yet this next one. We don't have the percent at all, so we're going to have to find the rate. And to do that, we take our portion and divide by the base amount. So here, the portion was the 32. The base was the 80. We divide and we get 0.4 as our rate. Then we want to convert that into a percent, which will be 40%. So as I said, that rate method is quicker and easier, especially if you're just punching numbers in the calculator, but you have to really know what you're doing so you know what pieces you have. Is this a situation where you have to multiply by the rate or divide by the rate, or are you looking for the rate? Typically, that rate method is used when you know the base amount and the rate. And it allows you to very quickly find that portion of interest. Now, there are a lot of applications in business and finance that use this, like commissions, interest, stuff like that. And we'll look at some of those examples later. For right now, it is break time. Okay, so we've looked at these calculations with percents. Let's look at doing some problem solving with percents. Like I said, that proportion method saves a lot of errors, even though the rate method is quicker. It's even more so when we look at word problems because that proportion method helps us line things up. For example, let's do SMH Corporation estimates gross weekly profit as 8% of net sales. Find the net sales for a week where gross profit is estimated at $587,440. So as I mentioned in the other problems, I usually start with the percent if I can. What's the percent here? 8%. So that's 8 over 100. Now before we do anything else, let's identify what those numbers stand for. So in the problem, there are two numbers we're working with. We have gross weekly profit and net sales. One of them is a piece of the other. Now, don't let the words gross and net confuse you here because it's not gross profit and net profit. They're not talking about the same thing. Which one here is the whole big thing and which one is the piece that comes out of it? Well, gross is usually the big one, isn't it? But here, the profit is a piece of the total sales, okay? So the 8% is actually the profit. Think about it, if you sell stuff, let's say you're selling garden sheds. If you sell a garden shed for $800, that's your sales. Well, that's not all profit, is it? Your profit would be what's left over after you subtract expenses. So the profit is a piece of the sales. Typically, gross is the big number and net's what's left over, but we worded these differently here of profit is gross profit is your profit after you subtract expenses, but you haven't taken out your overhead, like the rent of your building, electricity and stuff like that yet. Net sales is just your total sales minus any returns. So to set up the other side of this, the 587,440, is that the profit or the sales? That's the profit. That's why I went ahead and I labeled these things here, because in a problem like this where you have such a large number, your brain wants to make that the base amount, but it's not. It's the portion. The base amount's even larger than that. So when we go ahead and cross multiply and divide, we have 100 times 587,440. What is that? 7,343,300, I believe. Let's double check it. 100 times 5, 87440 divided by 8. 7, 3, 4. Oops, I got an extra 3 in there. Oops. No extra charge for the extra 3. There you go. So 7,343,000 is what we're estimating our profit at. Or not profit, our total sales at. So again, there, like I said, it would have been really tempting to consider that big number to be the base amount if we weren't matching it up in that proportion. So setting up the proportion and making sure we know what each part of it represents helps us get the numbers in the correct spot. Now we might have something like this. FML and Associates retains 12% of profit for a reserve. Do you guys know what a reserve is? So if you're a company, you take your profit, a lot of it you're going to reinvest into the business or you're going to draw it out as income. A reserve is money you keep in an account in case you have something goes wrong, equipment breaks down and you have to replace it, some unexpected expense comes up as your reserve. Yeah. So for a month, where profit is $483,000, how much should be put in reserve? So again, let's start off. What is the percent in this problem? 12%. So it's 12 over 100. And again, let's just take the time. The 12 is representing what here? We have profit and reserve. Which one is the piece, the smaller piece? The reserve. And the 100 is representing all the profit in this case. The reserve is the portion of the profit that you hold over. So on the other side, 483,000, does that go with the reserve or with the profit? So it's going to go top or bottom? Bottom. And then we'll go ahead and cross multiply and divide. 12 times 483,000 divided by 100. So we get $57,960 that should go in the reserve. Make sense? Well, let's take a peek at Sam charges $110 for an Adirondack style chair. The materials cost $72. Find the rate of profit. What's that? Adirondack? Yeah, I spelled it wrong. You get the point. There's a good reason I'm not a spelling teacher. So anyway, rate of profit. Rate of profit, there's actually two types of rate of profit. There's a rate of profit and then there's a profit margin. Profit margin goes off of the selling price. Rate of profit goes off of the cost. So we're going to assume we're going off of the cost here. But the first thing we need to do is to find the amount of profit. How do you find the amount of the profit here? Perfect. 110 minus 72 gives us how much? $38. So then our rate of profit, well, it's going to be blank out of 100. That's going to be our rate there. What goes on top over here? Careful. The 38, the amount of profit. The 72 goes on bottom, the cost. You had the right idea. So now we cross multiply and divide. 100 times 38 divided by 72. Gives us 52.7, 52.8%. So whatever the cost is, they make 52.8% of that cost back in profit. That's actually a pretty tight margin for something like that. I used to build lawn furniture and sell them. Something that costs $72, if you're selling it for 110, chances are you got more hours into it. You're not making much of an hourly rate off of that. So let's do KMA Corporation. Adds 12% to each bid for waste. What would the total bid be if materials are estimated as $48,320? So this is a very common calculation in construction, actually any other industry where you're going to be doing estimates based off of material cost. So what's our percent in this problem? 12%. So 12 over 100. The 12 here represents what? The waste. And that waste is calculated off of the materials cost. So the 100 represents the materials. On the other side, do we have the materials or do we have the waste? The materials. So that goes on bottom. So what's our calculation going to be? Perfect. 12 times 48,320 divided by 100. 579.84. Now, whenever we come up with the result of a calculation, we should always go back and make sure it answers the question. This number represents the waste. Are we asked to find the amount for waste? We're asked to find the total bid. How do we get there from here? We have to add that to it. You got it. So 48,320 plus $579.84. Did that go right? Nope, I missed a zero. That's why. That should actually be $5,798.40. That makes more sense. I thought that was a pretty low waste amount. So $5,798.40 gets added, giving us a total of $54,118.40 for that bid. Does that make sense? So now here's a case. This is what we refer to as a percent increase problem. In a percent increase problem, we're starting out with some sort of a full amount. And then we're adding something to it. We're adding an increase to it to get a new amount. In this case, the full amount was the materials. What were we adding to the materials? Some amount for waste. And what we ended up with then is getting a total bid off of that. Oops. Thanks for picking those up for him. So if we look at the percents of what we have here, the materials were the full amount. They were 100%. We were adding waste of 12% to that, which meant the total bid was 112%. So what we could have done here, instead of finding 12%, we could have found 112% of the 48,320. Now when we cross multiply and divide, 112 times 48,320 divided by 100, $54,118.40. Would have saved us that step of having to add it back on later. Now in a problem like this, it's the same amount of effort either way. But let's take a look. Let's say after a 30% markup on materials, a bid comes to, let's see here, $182,000. Find the amount of the markup here. So the percent that's visible in the problem here is what? 30%. So 30 over 100. If I look at what that 30% is, of course, the 30% is the markup. 30% markup. And it is based off of the materials. So the 100% here is materials. On the other side, we're asked to find the markup, so that's okay, that's what we're looking for. Is the 182,000 the materials? No, it's the bid after the markup, isn't it? So these percents don't work here. The 182 does not represent the 30 or the 100%. So this is where we have to use that idea that the materials, is the 100%. And we have the markup, it's 30%. So the bid is going to be 100 plus 30 or 130%. So the percent we're working with here is actually 130%. So it's 130 over 100. And on the other side, the 182 represents the bid, which is the 130%, 182,000. And now we cross multiply and divide. 100 times 182,000 divided by 130. Giving us 140,000. What does that 140,000 represent? The 100% was the materials, right? What are we asked to find? The amount of markup. So neither of those numbers represents the amount of markup. How do we get to our answer then? You got it. We have the 182 minus the 140. So 42,000 is the markup. The other side of that would be a discount. So if you were to go on and be a contractor, as a business person, you're going to get, some companies like Menards just call it a contractor discount. The name in the industry is actually a trade discount. So like you would go to the same lumber yard that a homeowner would to buy your materials, but the lumber yard isn't going to charge you the same price because during the course of a year, you're going to order $400,000 worth of lumber. The average homeowner is going to buy a few $100s worth of lumber. Well, now a few $1,000s. Anyway, so let's say if you receive a 12% trade discount. Again, all that means is because you're a contractor and not just a regular homeowner, you're going to get a 12% discount off materials. How much would you pay Sure. So how much would you pay for supplies place 3? Let's be. So anyway, 12% is our percent here. What's the 12% represent? That's the trade discount, right? The 100% then would be the normal price, the full price. So here we're looking for, well, what we have is the 3,800. Does that represent the discount or the full price? Full price. So if we cross multiply and divide, we'll find the discount. So 12 times 3,800 divided by 100 is $456. That's the discount amount. Are we asked for the amount of the discount? How much would you pay, right? So how do we find how much we pay? There you go. We take the 3,800 and subtract the $456. That's $3,344. The saving a few $100 here and there for that trade discount is worth it. I'll put it this way. I remember when I got to where I stopped doing a high volume business, to where the volume of business I do, they decided they just couldn't give me the contractor discount anymore. It really did kind of hurt because you're used to paying a certain price for stuff. Because my discount was like 14, 15%, depending on where I was at. It did hurt. So let's look at one. So anyway, let's look at one where, let's say Sam pays, let's see here. I'm just blacking out. $3,780 for supplies. After a 16% trade discount. How much was the discount? In other words, how much did Sam save here? So the 16% is the discount, 16 out of 100. And of course, the 16 represents the discount. The 100 represents full price. Well, we have the 37.80. Is that the discount? No, the discount's what we're looking for here. Is the 37.80 the full price? No, it's what Sam paid. It's after the discount. You got it. So here again, we have full price. We're subtracting that discount to get a price paid. The full price, of course, would be represented as 100%. What was the discount? 16%. So then the price paid would be 100 minus 16, or 84%. I've got my power cord before my screen goes black on me. So the percent that we're going to be working with in this problem is the 84%. So 84 over 100. On the other side of this, we have the 3,780. Yep, that is with the 84%. That's after the discount. And then we'll cross multiply and divide. So 100 times 3,780 divided by 84 gives us 4,500 is what that should come out to be. There you go, 4,500 bucks. That is the full price. Is that what we're asked to find? How much is the discount? Which means we need to subtract, which is going to give us 720 bucks. Okay. Those percent increases and decreases are huge. Like for us in construction, a lot of times when we have an ad for waste, we will actually go to that rate method. So if, let's say I'm going to add 12% for waste. What I would do is I would take my materials cost, and we said 12% is 100% plus 12%, making 112%. So what would that be as a rate? 1.12. So if I have materials of $12,300, if I'm going to add that waste to it, I'd just take my 12,300 times 1.12 to get my total, giving me 13,776 as my total. So that waste factors for a couple of things. One, literally for waste, especially if you're shingling, there tends to be a lot of waste. It's also to insulate against price increases and stuff like that. Okay, we got a couple of assignments here. In the big book, the big thick book, yep. It's going to be page, we'll keep it fairly simple here. Actually, I got to get the correct edition here. I'm going to grab my book to make sure I'm getting you the right page. Like I said before, your book is 2 editions behind the one I'm using in my regular class. 151 maybe? Nope. 171. This book is in rough shape. So it's page 171. Exercise 5-6, page 173, exercise 5-7B, page 175, exercise 5-8B, and then also in the little book, Unit 16. So we have about 14 minutes here if you want to get started on those. Also, I'm going to give you the quiz to take with you that we'll do in class on Monday. The good news is that will be our last quiz of Unit 1. The bad news is that means Unit 1 test is coming up here soon. We don't do them together, we just have time to work on them.